In this video, we're going to take a look at dictionaries in Python. Dictionaries are also referred to as associative arrays, associative memories, hashes. There's a lot of names for them, but they all follow a particular pattern, and that is they have a key and a value combination, a pair of key and value. You will see them all over the industry. Let me give you a simple example. Let's say I open up a browser and I do a search for the word test. If I look at the URL, I'll see that it searched through Bing and it had a query and test. So this would be the key and this would be the value that it's querying. It has other things here, like I'm using some kind of Mozilla browser, because I'm using Firefox in this case. I assume this has something to do with Mozilla as well. But you can see that they have PC is the key, Mozilla looks like the value, form is the key, Mozilla browser would be my guess at this. And if you watch, you'll see that happen quite often on the internet, but also in lots of other places as well. Key and value pairs are a very common way of storing data. So in Python, let me show you an example of how it would work. I'm going to go ahead and copy this code out, and we'll take a look. Okay, first couple things to note is that instead of using square brackets, you use curly braces. So that's a bracket, that's a brace, that's a parenthesis. So you use braces. Second thing to note is that you need to supply a key along with the value. And the key is just some string of characters you make up. Now, it is possible in some languages to use something other than a key, string key, I should say. But in most languages, they're looking for a string of characters as the key. So I know fundamentally that One and Bob Smith and bsmith@hotmail.com are the ID, name, and email address of my data. But with the dictionary, I can actually go through and label it by putting the key, a colon, and then whatever value I want. I can continue that combination of key and value to create a row of data. Now the advantage of this, of course, is that it's self-describing. That's a nice feature. If somebody looks at that row of data, they realize that One indicates the ID and Bob Smith indicates name and so on. So it is a nice feature to have. As such, of course, it also has additional overhead. Not only are you storing the values, but you're also storing the identifiers in the form of keys. Still, it's pretty handy. Now, if I run this code, you can see that when I print it out on line 13 and 14, down here are the results. It prints out differently depending on whether it's a list or a dictionary. The print statement is actually showing the curly braces for the dictionary and the square brackets for the list, as we've seen previously on that one. If I would like to extract out an individual element out of that collection, we know that we can use an index value like 0, 1, 2, 3 to extract data. In this case, the 0th member is the value 1. The first member is Bob Smith. So when I ask for the first element of list, I get Bob Smith. With the dictionary, it's unordered, but it's based on the key. So you ask for the key and not the actual element by its place. Oops. Sorry, guys. I know the mouse wheel is not much fun. Let me go ahead and change this a bit. Put a 1 in there. I'll run this. And you can see that with Python, it doesn't like you using an index for that. It's actually looking for a string. Now, there are some languages where you can do one or both, but many demand that you use a key, and it has to do with set theory, in which case a set like this should be unordered. So it's not very hard to use a dictionary. Certainly they're a nice tool. Easy to work with. You can actually nest them if you want, although it can get a little confusing if you do that. So to keep things simple, you may just want to actually go through and use a dictionary to create a row of data, a single list of self-describing values, and then use an actual Python list to create your table. I think that's a real easy way to go. I think most people will find that a good way to kind of keep it in their mind as far as what you've got. You can see here on my results that I've printed out my table. This is under multi-dimensional list. And I've got the rows of data in here as a dictionary, ID, email, and name. You notice that I actually put it in as ID, name, and email, but because it's unordered, it came out differently in this case. This display is probably sorting it out based on the the order of alphabetic order of the element name or key names. Let's see if I can prove that. I'll put in a here, and we'll run it again. And let's see, name. Nope, it just didn't seem to make much difference. It's just unordered. It's interesting, last time it was ordered alphabetically, this time it didn't seem to make any difference. But that's fine. Again, it's by definition, these type of sets are defined as being unordered. So I'd be somewhat surprised if it did. It's pretty easy to work with this way. Again, you can think of it as being a table. The difference is in my table here, I don't have any way of distinguishing which is the ID, which is the name, and which is the email. And of course for humans that's pretty easy to figure out, but with machines, or maybe the data is much more complex than this, it might be nice to actually indicate that on a row by row basis. In the previous exercise, I went ahead and just made a row that was header information at the top, and that's perfectly fine too. But as we've seen in the industry, other options exist, and such as when you're using a web browser and you have a query string at the top. This is what the dictionaries are good for. Now, if you do have a list, you can actually just go through and loop through your row of dictionary objects really quite easily. For each row in the table, you just print it out. And you can see that I did that here. for each list in the table, email, ID, name. It just printed them out. There's functions you can use to extract data out of a dictionary that do not exist in lists or tuples. Here's an example. I go through and use items to extract values out of the dictionary. I'm looking for key information and values. It will unpack it in this manner. And so when I go through, the key will be extracted. I'll just print out the key name, ID was the name, and equals value. Items will extract it in that order, so you've got to make up variables that will capture it as key and value. The names don't matter. It could be X and Y for that matter, but I think it makes it easier to read if you put in key and value. If I do that, then of course I can print things out in my own custom format instead of just relying on the print's default format. You can also just go through and ask for the values. It's printing it out as a list of values here. Or you could ask for the keys. It also prints it out as a list of values. Of course, these values are the actual keys. They're kind of nice. One of the reasons why you need to learn about them is because they do show up in other languages. You don't use them nearly as often as you would with just plain lists. But they do come up. So we're going to do an exercise next, and I will see you there in that video.